Basically, I have a disadvantage that many of the people who have come for the session have not been there in the earlier sessions. But I have an advantage that many of the things which I was supposed to speak have been covered already. And Sajid is also going to speak next. So a substantive portion of that is also is going to be covered by him. But what I would like to look at is to look at the industry 4.0 in totality, so that we can make some plan towards industry 4.0 in the context of post-Kerala, in the context of rebuilding. The Chief Minister had made it clear that it is not only just reconstruction and rehabilitation, but it is going to be building up a new Kerala. There is a very important thing that when Edison's lab, which was a very costly lab, was burned, he was in joy because he thought that he could build a new lab. So we have similarly an opportunity for building up something great in Kerala. I mean, given the sort of solidarity which the people of Kerala had shown in the context of the flood. So basically, I'm trying to put together what Professor Klaus Schwab, a French economist who had put forward, who is the founder and director of the and executive chairman of the World Economic Forum. He had proposed in 2016, looking at the technology situation world over, that we are on the verge of the industry 4.0. So this is in fact the slide which Klaus Schwab himself presented before the World Economic Forum. I will not be going into too many. I mean, I might be accused of bringing out a rosy picture of Industry 4.0. There is no issue. But I will just cover something in this slide, essentially, which talks about, number one, disruption to jobs and skills, which has been focused recently in the Chinda special issue by Professor C.P. Narayanan on the 800 million job loss that is going to be created during the coming 5-6 years, which would approximately cover 25% of the people employed world over. So this is going to be a major challenge. This does not cover the loss of people who are in, for instance, IT and related sectors, who would also lose jobs unless they reskill themselves. That is a portion of the story. But of course, as we had similar issues when the internet was coming up, but we also have seen that a lot of new job opportunities had been created, and so there had been some balancing. But definitely in terms of artificial intelligence and robotics taking up a number of positions, the real estate, insurance, legal services, administrative assistance, courier messaging, drivers, these are all segments which are going to face a huge loss of opportunities that are going to come up. Now, then I would also touch upon the innovation and productivity aspect, which is one of the most widely debated issues on Industry 4.0. The total factor of productivity studies on the US workforce very clearly shows that the economy remains sluggish and is not likely to get transformed. Many of the optimists say that this innovation is going to make a huge change in terms of productivity and also in terms of the economic growth. But there are a lot of people who are very doubtful about that. And there are also people who are indicating that the platforms and the economy of the platforms create quite a lot of intangibles which are not captured by the present parameters of national income calculation. Now, the third aspect on inequality. I mean, as we now know, a majority of the people in computers, mathematics, and engineering related areas are men. And naturally, the Industry 4.0 revolution is going to create a huge gender gap as is projected by many of the people. So this is regarding, I mean, whatever negatives or cons regarding this. And then apart from that, what we discussed regarding cyber security in the morning when Dr. Krishnan presented how the Iranian nuclear plant centrifuge was, hacked and problems created, and how Ukrainian power stations were, the PLCs were modified and problems created. These are all issues that we will have to handle. And apart from that, there are ethics and identity issues, the debates that are going on in the context of the internet being brought under control and things like that. These are also going to come up as major issues. Now, fusion technology is basically the digital platform, the peer-to-peer financing models, the IoT-based remote services. These are going to transform the existing industries very drastically. And also the B2G and B2C and B2B interfaces are also going to be drastically transformed as a part of Industry 4.0. Now let us go into what is going to be the overall gamut of what we are talking about in terms of industrial revolution. Fashionable to talk about a little bit about history. We look at revolutions in the past. The agrarian revolution, which took place 10,000 years ago, where production transformed from basically the hunter-gatherer society to the settled life and increase of fruit production, followed by the first industrial revolution, where you have mechanical production facilities using steam power. Let's go back to the earlier slide. Go back to the earlier slide. Okay, well, the second industrial revolution were, division of labor and mass production using electrical energy. The third industrial revolution, which is the one which we are in right now, manufacturing automation and using electronic and IT systems, and also hardware automation, PLCs and all that we had been talking about apart from the internet and web were features of that. And then we go into the fourth industrial revolution, where the focus would be on cyber physical systems. Can we just run through the slides? I have a deck of 90 slides, so I might skip quite a lot of slides because I don't have time for that. So this is what we talked about, the agrarian revolution. Then, for completeness, I am running through the first industrial revolution, where artisanal production was transformed into machine-made production, and human labor and animal labor was replaced by mechanical labor. The third industrial revolution, where you had Taylorism, workflow transformations, and electricity and communication coming in a big way in terms of expansion. Then the third industrial revolution, where we see the mainframe. Interestingly, even after 50 years, the mainframe, we see that the top 100 global banks still run on mainframe. 100% of credit transactions still run on mainframe, and 99% of the 500 companies all depend on Fortune 500 companies all depend on mainframe. In spite of the tremendous gaps that breakthroughs that we have made, we still have the mainframe running strong after 50 years. And then we had the PC revolution, followed by the internet and the web. And industrial automation was the main piece of the Industry 3.0. Which has been driven by programmable logic controllers, which run the supply chains, robotic machines, and stuff like that. Now, for the Industry 4.0, we would be running into primarily software automation, that is, and fusion. These are two major aspects of Industry 4.0, which we will now focus on. Now, again, as a part of the third revolution, I will just run through this. This is regarding the third industrial revolution. All we know that micro miniaturization had been a major part of that. I'm just trying to build blocks on that, because the Industry 4.0 is based on micro miniaturization. Can we go to that slide? Yeah, you know the famous comparison of ENIAC, which had 175 kilowatt and lights dimmed in Philadelphia, with the iPhone. You compare 800 milliwatt and 25 billion instructions per second. You have the Moore's law, which continued, but now under transition and changes in the context of the nanotechnology revolution. The convergence, which had brought down the cost of communication, 1927% price, $75, coming down to $0.3, and the number of hours of work coming from 200 to 0.02. This is a sort of transformation and production of cost of technology which was possible through digitization. We have huge privacy challenges with the convergence of the content communication and computing. These are all, aspects of the third industrial revolution, which are well known, what we call about the digital revolution. Now let us go to Industry 4.0. The Industry 4.0, as I indicated earlier, is the fusion of the digital world, which we have built up as a part of the Industry 3.0, the biological world, and the physical world. This makes the big difference. Beyond the Industry 3.0, this fusion is making the big difference. I will have to run a little bit through the biological transformations. I know nothing beyond my 10th standard biology, but I'm just trying to run through some of the things because they are extremely important. Gene sequencing, let's go to that. So this is, I think there is one more, the 3 more slides you have left out. Gene sequencing. Go to the 2 slides behind that. Or is it the slide? No, before that. There are 2 slides before that on gene sequencing. Okay, you locate it. Okay, basically what we are talking about is, you all know about the advances which have been made through the Human Genome Project during the period 1990 to 2003. This was a $2.7 billion program, and it took nearly 13 years for the process of gene sequencing to be stabilized. This is the cost of gene sequencing as it comes down. It is now done in a few hours and for $100. This has made the processing of gene tremendously. As you all know, genome is the genetic material present in a cell, and basically what we do is, through a process of electrophoresis, we separate the DNA, radio label it, and then use an X-ray to capture the genome sequence. But this has now given a lot of opportunities for looking at pathological issues, for looking at growth issues, and things like that. This is going to be the major landmark of the Industry 4.0. This is, these are cells, living cells, which are created from biopolymers, and these are called bioinks. It is possible for us to print using 3D printing devices actual cells. You make clusters of that, and then you finally create living tissues. This is reality. There are companies which actually build this right now. What does that mean? That means that I have an ulcer on my foot. It is possible, if this works out, for me to use a 3D printer to print the cells onto the portion where the ulcer happens. So this is what we are talking about. Next. The future vision on this is what we talk about synthetic biology. Basically, if you want to do a cosmetic surgery, you can have laser cells burning away the unnecessary portion. You can make a 3D model of your nose if you find that your nose is not smart enough, and you can just reprint to order, and also you can create transplanted organs based on this technology. This is what we are talking about, synthetic biology. Next, we come to one of the major problems that we face right now is the discrepancy between the number of transplant requests and the donors. We have in 2015 $1,19,362. The number of transplants which are required. The number of donors is only 33,612. A solution which is Industry 4.0 is bringing into is xenoplantation. Now, for any body of any part of the human body to be replaced, now we were talking about baboons' parts being brought into our body. It has now been found that the pigs have the best physiological similarity with the human bodies, and less risky when you transplant a part into the human body. Especially the organs. Yeah, especially the organs. So the xenoplantation, here there are 3 things. One is the pig. It is genetically transformed so that the portion of the pig which is brought into our body is not rejected. The human body has a tendency to reject. There have been a number of exercises of transplants in the past. Immediately the human system would reject that, but genetically this is transformed. The pig kidney comes here, and normally the human immune system will push this out. But what we are doing is we are also taking the pig bone marrow, and then we are impregnating that bone marrow into the body, and we are making the human body believe that the immune system of the human body believe that this kidney is the same as a human kidney. So these are sort of xenotransplant options that are coming up. Next. I'm taking the liberty, Dr. Unnikrishnan is here, who is a physician. I have no business to talk about biology before him, but anyway, the slide that we had picked up earlier. Gene sequencing, I നേരത്തെ എടുത്ത സ്ലൈഡ് അങ്ങ് പോയാൽ മതി. നേരത്തെ പോയ ലിങ്ക് അതിലേക്കാണ്. Gene sequencing, gene editing. So this is a very interesting breakthrough which has been made by the Chinese, where they essentially, which was reported in Nature magazine on November 15. This is before the embryo gene editing controversy which happened recently. Basically what they did is that, see, human systems, when tumor cells are in the body, there is an immune system response to that and interact with that. So here, using a technology called CRISPR-Cas9, and the tumor cells, what they do is they actually align with the PD-1L cells. The PD-1L cells are programmed cells of death, basically. They get locked to the tumor cells, and the tumor cells prevent destruction of those cells by the immune system. So this is one of the challenges that we face when you have cancer. And now what they did is that they have edited the PD-1L cell genetically, and it is possible for the tumor cell, the immune system to attack the tumor cell effectively, which is going to be a big breakthrough in terms of cancer treatment. Now I would novel neurotechnologies. There are also a similar segment in biology, that is the novel neurotechnologies, which is slightly controversial, but a lot of possibilities are coming up. Transcranial brain stimulation, basically magnetic stimulation on the brain. It's a non-invasive procedure by electrodes or coils kept above this. It is used for treatment of depression and various other conditions, and also it can improve the mood of the people also by using magnetic waves. Deep brain stimulation, this is sort of a invasive procedure where you have a pulse generator in your body and use the signals to the brain. That can be used for treatment of dystonia and Parkinson's disease. Next. Brain-computer interfaces. This is you can use non-invasive recording electrode and invasive recording electrodes, and use signal processing and use that for movement of prosthetic limbs. And if you are sitting in a wheelchair, a disabled person, it is possible to use those signals from the brain for actual movement. There is also a major breakthrough coming up. So these are all regarding whatever great breakthroughs which are coming in the context of the biological changes that are happening. Now this also raises a variety of ethical issues. Number one, germ alterations, germline alterations, basically the genetic modifications in the human body can have mistakes, can create very complex situations. Then there is going to be a new mechanism of inequality that is going to come up. People who have access to these technologies, farmers who have access to these technologies, and people who don't have access to these technologies. So these are all very serious ethical issues, leaving the commercial and military issues that can come up. Now let us go quickly to nanotechnology. Nanotechnology, we all know that this is basically a fusion of a variety of technologies. Surface science, which looks at the issues across the phases of tube, for instance, solid, liquid gas, vacuum, liquid, and stuff like that. Energy storage, microfabrication, molecular engineering, by transformation at the molecular level, what can be done in materials, semiconductor physics, and molecular biology, where you manipulate DNA and stuff like that. So this is the segment of nanotechnology which is going to be very critical in the physical part of the transformation, which is brought out by nanotechnology. I'm not running through all the use cases. One or two things for getting a feel of that. Diesel engines produce sulfuric acid and formic acid as combustion products. Technologies are available where nano zirconia powder can be deposited on the diesel engines, which can substantially improve the corrosion by something called the Lotus effect. Carbon nanotubes, this can be using this filtration. You can have achieve 99.99% efficiencies in water filtering. Next. Similarly, diesel oxide catalyst using palladium and platinum can use the vehicle standards. Solar panels, tremendous possibilities, moving from the crystalline silicon to gallium arsenide and now to nanomaterials. The efficiencies can be as high as 65%. The installation cost can be substantially reduced because the nanofilms can be folded and can be structured. So this is going to make a huge transformation, and companies have started producing that. And quantum dots, they can improve the efficiency even further by using microexcitron technologies, where the number of electrons that create the photovoltaic effect can be improved. Nano structures, where essentially we are talking about bringing two non-exclusive factors, that is toughness and strength. For instance, if a ceramic plate is tough but not strong, but a rubber ball is tough and it is not strong. So these are two things which can be, these features can be combined in acrylic material, and that is what nanotechnology is talking about. And fuel cells could not be commercially realized basically because of the costs involved. It requires platinum catalyst, but nanoparticles, this can be reduced substantively. The efficiency of the fuel cells, both the electrodes can be replaced now by carbon nanotubes, and this is also transforming the segment substantively. Now coming to renewables. I'll just touch upon some things because we had a session yesterday by GM Pilla, and Sajid is also going to talk about. Now, the oil market down and the Paris Agreement are now creating alternate spots. There are three elements to it. One is the storage costs are coming down, EV is going to be very popular, and the renewable costs are also drastically coming down. The EV share of a 40% growth in EV world over. Today morning, Reggie Pillai was talking about Shanghai, where Shenzhen has massively switched over to. So 79% of the global oil demand right now in transport and petrochemicals with EVs, this is going to be by 2020, this is 2035. There is going to be an explosive growth in EV, reducing this consumption. The wind costs are going to come down by 50%, energy storage costs by 80%, solar costs by 60%, and this is going to transform the renewable sector drastically. I will not go to quantum computing basically because quantum computing is still not, of course, operational models are available. There is a video on that. I won't have time to run through it. Basically, things which the computer is not very smart at, basically optimization and also very complex decision making, which requires large number of iterations where computing power is a challenge in supercomputers. This is the area where quantum computing is going to make a change. So these are basically the physical and biological aspects which we continue through. Now, autonomous vehicles, quite a lot of that, and drones have been talked about in the morning by Reggie Pilla. I will not run through. Basically, these are all patents which are pending. Let us go to the next slide. Google had tried it out in 2012. 2020 is going to be the disruptive in terms of the autonomous vehicles. What we are looking for, the target is 275 million miles is the time that is required to test that the autonomous vehicle is safe to run on the road. And if you have the roads required for that, autonomous vehicles are going to be a reality. And 2025, all these companies are going to have autonomous vehicles produced world over. Delivery drones, I mean, this has been talked yesterday, today morning by Reggie Pillai. A number of locations, delivery drones have already started up, and this is going to transform the medicine delivery, foods delivery, and materials delivery substantively. Autonomous underwater vehicles, they are also going to transform our sensor and environmental monitoring and things like that. Microsensors through the multispectral imaging, using drones again, soil analysis and pest analysis are going to be reality. This is being tried out in locations on scale. In the context of Kerala also, we will have to look at some of these things for making precision farming a reality. Now, just touch through a little bit on 3D printing. Slide Margola. Okay, you have basically a number of manufacturing techniques which we usually talk about. The subtractive process, when we do sculpture on a when you do a sculpture, we are actually removing portions, and that is called subtractive processing. In printing, what you do is 3D printing. Basically, the process is just reversed. You have additive printing. You have this one of the process which has been developed by MIT, where an inkjet moves and a bed of powder is used for coating 3D materials. So this is possible to do with polymers, plastics, and even with metal. This is going to transform the physical situation very drastically. We have this working in Fab Lab. For me also, this was science fiction, but the startup mission has the Fab Labs running, and so 3D printing is, I mean, we can look at that anywhere in Kerala. Through the Fab Labs, we have the 3D printers running, based on which you can make models and improve things. Let us skip this. So a number of methods are there, laser powder methods and stuff like that. These have got various advantages and disadvantages. The metal printing is going to transform the aerospace, automatic, and even medical sector by surgical instruments. There is no necessity for you to get a instrument surgicalized. What you can do is you can just print a device and then start it for the operation, which is going to be extremely safe for the operation. So this is sort of things that we are talking about as a part of that. And we have 4D printing, where we have a small MIT 4D printing surface video, where essentially a new 3D printed products go through a change and through an external energy input, and this box will now actually get folded up when it gets into contact with water. This is what we are talking about, 4D, and with environment stimuli you can actually create movements and triggers. That is what we are talking about, 4D printing. This has been this is available on the MIT site when we are talking about 4D printing. These are all going to get into products and stuff like that. Next. Now, robotics, a little bit had been talked about in number of healthcare and agriculture sessions. These are all no longer, fictional stuff. These are all going to be reality. We have the robot which has been developed by the startup mission, which is used for manholes for cleaning that. That became a big story. So this is going to, the robot milker is going to be very highly productive and high quality milk that is coming up. These are all huge opportunities that are coming up. And in terms of materials, we have graphene, which is 200 times stronger than steel, and at the same time, million times thinner than the human hair. This material, of course, is not commercially made possible because the cost of graphene is very high. But it is expected that during the coming 3 or 4 years, graphene is going to be a reality, creating a huge change in terms of material science. Now, polyhexohydrotriazine, it is basically a thermosetting plastic. It is fully biodegradable. So the advantage of this that it is not going to make any impact on the environment, and it can be used for replacement of screens, displays, and stuff like that. I just run through this because basically the things which people had been talking about in Industry 4.0 are around digital. People are talking about blockchain, people are talking about machine learning, people are talking about ML, IoT. basically we are limiting ourselves to the digital and not looking at the physical and biological segments. Now, a few things, Internet of Things has been already covered, and blockchain, Dr. Krishnan has covered. I will not go into that. 5G technologies are going to make a huge change. Because little bit was talked about by, this is the transformation that is going to come. This is the 1G, our analog phone, 2G, our digital phone, 3G, our person's smartphone, which transformed coverage and made internet conversation on the mobile possible. 4G, this is going to transform the situation, going to gigabit. And now when you go into 5G, we have huge potentials in terms of more than gigabit speed and also connection to smart grids. The last and most important thing, of course, Wahid had covered this in his technology platforms. The huge challenge that, the huge change that Industry 4.0 is going to bring is the topic of the 2014 Nobel Prize by the French economist Jean Tirole. He was awarded the Nobel Prize for his model on MSP, multi-sided platforms, where essentially you have a mechanism for interlinking the side A and the side B, which is not possible in a product platform or a reseller. In a product platform, we buy raw materials, take it to this point, and then you distribute. There is no conversation between these two. This is what is possible in multi-sided platform, and it is making tremendous what Uber does and what PayPal does, what eBay does, what Google does. Everything is based on the platform phenomenon, which is called indirect network effect, which was the major hypothesis that was put forward as a part of that. Basically, what this talks about is the value of the customer on one side increases with the number of customers on the other side. So you see that in Uber, if you have more drivers, the prices are low, you have faster pickup, you have wider geographical coverage. If you have more passengers, then you have less idle time of drivers. So these are all reinforcing on the platform. This is the model for Airbnb and stuff like that. So I'll just, the ingenious pricing models are also a very important thing. We have seen this ingenious pricing model. Basically, Uber Eats now, Trivandrum is enjoying the Uber Eats because there are concessions which are offered by them at times and particular products and stuff like that. So this is a very interesting mechanism where they drive essentially to build the critical mass, and various demand acceleration, supply acceleration strategies, and also expanding into niche markets are the strategies which are being adopted. So these MSPs is a major thing that is coming up as a part of the industry 4.0. I will now just close this with the issues of governance in the industry 4.0 segment, where essentially the technology providers are brought together. I'm just bringing two models. One is the Silicon Valley model, and the other one is the Shanghai model. The Silicon Valley model, well-known model, unparalleled access to high-quality engineers, risk-taking culture, venture capabilities, and superb universities. All start off with Ford, Lockheed, and IBM. In response to the Sputnik launching, the Americans were heartfelt, crestfallen, and they brought these, the American industry, moved them into the Silicon Valley 50 years back, and that started off with exercises of the Silicon Valley. The Fairchild and the Fairchildren, Intel, AMD, we know that they are all manufacturers of chips, and NVIDIA is also a manufacturer of chips, which is now bringing out ML chips and graphic chips. They all became part of the hardware industry, and NASA was basically to meet the needs of NASA. And this is how the Silicon Valley was built up in 60s. Now today, we have the based on the flourishing hardware industry, there was a software and internet industry which was built up through the major players. San Francisco, the Bay Area, right now receives more than 50% of the total venture funding in the US. And you have a large number of excellent incubators promoting tech startups, education startups, health, game startups has been also created. This is in fact one of the major drivers of Industry 4.0 in the Silicon Valley. And the most important part of it, Stanford University with 21 Nobel laureates, the California University with 7 Nobel laureates, Berkeley University with 4 Nobel laureates, the Stanford Research Park, which transfers the technologies from the university to the industry, and the alumni from Stanford, which has created 7,054 companies and 5.4 million jobs. This makes the difference in Silicon Valley. If you look at Shanghai, it is a new entrant in China into where, Dr. Parashuran is working with the university in Shanghai. Now, Shanghai had a disadvantage because none of the major internet players, Baidu, number 8 in internet in the world, Alibaba, number 6 in internet revenue in the world, Tencent, number 4 in internet revenue in the world. None of these companies belong to Shanghai. They all belong to Beijing, Hangzhou, and Shenzhen. But now Shanghai is a major pickup on the startup zone. Fudan University, it is the 100th, world ranking is 100. The Zhejiang University, 300, and East China University, 437. Still among the 1.5% of the best universities in the world. This is driving the transition. This academic base is driving the, of course, they have got excellent manufacturing base that is available, and also huge entrepreneurship program which has been driven by the Chinese government. For the last 40 years, China has been running this huge transition and restructuring of their financing models in the high technology center. Now, Chinese government is the largest VC investor in the whole of the world with $231 billion in 2015. And look at the transition that is happening. The public labs, government got linked up immediately after the, during the incubation phase. The firms and universities are also linked up into a common ecosystem with the firms, the private firms at the central government. This is making the biggest transition in terms of, you look at the number of patents, look at the number of research projects which are coming up, the number of new startups which are coming up. China is making a big transition, and this is because primarily centered around this policy. Now, coming to the Kerala scenario. In this context, we have lost the earlier electronic revolutions. I don't know about what happened during the first industrial revolution in Kerala. Shashi Tharoor had talked about something about the second industrial revolution in the Indian context and how how we lost the opportunities in that. But anyway, in the Kerala situation, no documentation is available. The question is, of course, Industry 4.0, there are cons about it, there are a lot of pros about it. What are the possibilities of Kerala in the context of the Industry 4.0? I don't have the depth and grasp to how to make a futuristic projection on the Kerala scenario. But we find that Kerala has got a number of positives, but a number of serious gaps also. That is what I just want to bring to the table. The IT secretary it would be not proper for me to talk about what are these initiatives, but I've just run through building Industry 4.0 capabilities. This is a major area which has to be addressed. Nothing much has been done apart from whatever ICT Academy has initiated and whatever the startup angel funding, some initiatives have come up. Now, building a coordinated ecosystem, huge efforts, which has transformed the IT sector in Kerala. The Airbus Innovation Center, Kerala Technology Innovation Zone, the Tech Mahindra Development Center, the Ernst & Young intervention, the Space Park program, the Nizam, which is, phase 3, already 25,000 square feet has been occupied, Taurus, which is going to come up, Technocity. Huge activities have come up, which has taken the Kerala IT segment several steps forward. We had the hash blockchain, we had the hash huddle, and we had the building the ecosystem. Okay, now Keltron has also entered into laptop and server manufacture with USD Global and Intel K4, a huge program is going to come up to create GB connectivity throughout the state and free internet to 2 lakh households. These are all excellent. We have made huge, breakthroughs in terms of creating a coordinated ecosystem. Planning the future workforce, the accelerated blockchain development program, which is driven by the Kerala Development Innovation Strategy Council, the ICT Academy, and the Kerala Blockchain Academy, is the largest blockchain training program which has been initiated. And ICT Academy is also running a number of things in the process automation going to be started. IoT workshops are being done in colleges. Even though these are things which have not reached a substantive critical portion, we have made dent into these areas. Can we go to the next slide? Now, increasing funding to incentive risky industry forces. Also, we have made a model. Startup Mission basically has been driving this. We have the Thai Angel Network, the Kerala Angel Network, and all are in place, but the scope of operations are very limited. There is absolutely no comparison with the venture funds which are available elsewhere. But what is worrying is you look at the distribution of startup by domain group, the latest study which the Startup Mission has done. The segment in biology is 3% of the total. The segment in physical is 18%. A large chunk of it, 9% is new technology, is out of 2000, and this is primarily digital. Right? We are not in a position to move into biology as well as physical sector. This is going to be the biggest challenge that we are going to face in Industry 4.0. We have strong areas. Whatever interventions that we are doing is primarily digital, which means that the IT department is doing quite a lot of things. The science and technology and education segments are not at all making an effort to leverage the possibilities of Industry 4.0. Serious gaps in life sciences and material sciences. Our academics, the universities are nowhere. The highest ranking university in Kerala is the Kerala University, which has got 1,000+ ranking. None of the other universities, the Fisheries University is 7,000 ranking, Veterinary University is 5,600, the Agriculture University is 6,000. This is sort of international ranking that we have. We have huge gaps in terms of life science and material sciences. There are hardly 20 people working on nanotechnology in Kerala, in the Fisheries University, and Mahatma Gandhi University. Nothing much is being done in terms of material sciences. Unless we make a dent into these areas and bring this together, it is not possible for us to leverage the Industry 4.0. There are huge gaps in hardware with Keltron, and now, something would come around the hardware manufacturing. Otherwise, a large number of component manufacturers are around. They are all looking for an opportunity to come together. ESD, we have got, in terms of design, a number of companies are making, designs for foreign products, but nothing is manufactured. We don't have a manufacturing base in Kerala, and we have huge gaps in economy. These are all very serious challenges as far as Industry 4.0 is concerned. With this,